Given you some function, they want you to figure out what price should they sell the shirt at to maximize revenue. At this price, how many would they sell? So basically, what are you looking for?
P.
P. So we need to find, basically what we need to do here, guys, is find the zeros. All right, we want to find we want to find the x value at we want to find the maximum here. The x value is going to be the p value, and then the r value, when it equals, is going to be your maximum revenue. So when you think about what this would look like, it's got a negative a squared, so it's going to do this. I know that it starts at the origin because there's no c value. Everybody okay with that?
Yeah, if we wanted to, could we switch the negative?
And I was just about to say that. In my mind, I would normally say, hey, this is the same thing as saying negative 200 p squared plus 8,000 p. Because look what I did. The same thing. See, great minds think alike. Hey, you're like finishing each other's sentences. She rolls her eyes and she laughs.
No, I didn't.
Yes, you did. In this case here, wouldn't it be really easy just to use axis of symmetry to get the x value? Opposite of b over 2a. It's a very, very fast one to work with. Opposite of b would be negative 8,000 divided by 2 times 200, which is negative 400. And now we know it's going to be positive and drop some zeros. What's 80 divided by 4? 20. And what does p represent according to the problem?
Price.
The price. The price of your shirt. Shirt needs to be 20 bucks. How much?
You get 400.
Opposite of b over 2a. Remember, your axis of symmetry is opposite of b over 2a. That's it.
I thought you wanted us to like factor like from the zeros.
Why? You don't have to. Because they're asking you to figure out what price should they sell the shirt at to maximize revenue. So you're trying to find basically the value here that gives you that maximum. Because according to the equation, the p value stands for price. What it equals then would be the annual revenue. So that's what it works as. So that x value. Yeah, in this case.
So you just found the axis. So now you plug it in and find another.
Yes, ma'am. Yes, ma'am.
Or you can just see what it is.
Or you can just follow ahead and use your calculator. But in this case, you'd have to mess around a little bit to try to adjust your windows and find the maximum and all that. But it's not going to be, it wouldn't be horrible to figure out. Okay? 8,000? Yeah. That's what I have.
Oh, so then you put the
Yeah.
20 back in and find out how many.
Yep. The second problem, after I ran this off, I realized I forgot to write down the equation of what it would start to look like. Anytime that you have a initial velocity style problem, remember I will give you the generic formula. This one's asking you to come up with it, but by now we might be able to figure that out.
Negative 16t squared plus v sub 0
Yeah,
t
very good.
plus 8.
Good. Oops. All right, mine are out of order. Here we go. The only thing that's different with this one is that, you know how we've been using negative 16 because we've been in feet? This one talks about in terms of meters, which is negative 9.8 meters per second squared. So the generic formula to start this problem would be negative 9.8 t squared plus 15t plus 1. Because it tells you that it has a ball is thrown upward at an initial velocity of 15 meters per second at a height of 1 meter above the ground. That's the formula that you would be given. Okay. From here, they would ask you, write the equation for the height of the ball. Well, that's the equation that will determine, bless you, the height of the ball. Because in 0 seconds, where's the initial height? 1. Very good. As you move your glass up with one finger, then you're telling me it's 1.
Me?
Yeah.
Oh.
It wasn't funny. I was telling you were right. At least you're using your pointer finger. What is the height of the ball after a second? What do you replace t with?
1.
1. Okay. Now, would you do that by hand or would you throw that in your table?
Throw it.
Throw it in a table. Because are you going to screw up if you do that by hand?
Probably.
Will the table do the calculations for you? Yeah. I would throw that in my table. After how many seconds does the ball land? What are you looking for?
0.
0. So if we do this, I haven't done this in the calculator yet myself, but I'm curious if it is a clean number. So we have negative 9.8x squared plus a 15x plus a 1. Go to my table, and at 0 it's 1, that's good. That's after 1 second it is 6.2 meters in the air, and then it falls back to negative real quick. So this one doesn't take long to go up and down. Adjust my window here. All right. So it doesn't. What I did is just to readjust my window at 10 by 10. Excuse me. And then I can go through it and figure out how long it was in the air for. We know it started at 1. We're at 0 seconds was at 1 meter. It got to 0 meters by hitting back into the ground. What button do we have to press to find that value?
Second count. Second trace was
Not trace. We want to do. Oh, sorry. I know where you're going. I thought you were going to trace your numbers. My bad. So second trace, correct. And then which one?
0.
Option number 2.
It's 1.59.
Whoa, whoa, whoa! Enter, enter, enter. After roughly 1.59 seconds, the ball went up and down.
So you're just trying to see when it's in between positive and negative, and then you find where.
Yeah.
So you want to, like, you look for like the exact number on
Yep.
one, two, 1.
Yep, and that's by using that second calculate 0 function. That's how it allows you to bounce back and forth to figure out where it's going to look for the actual value of 0. Because what it's doing is that within those two boundaries that you set, the left-hand boundary and the right-hand boundary, the calculator is making all the different calculations for the values of x, and it's searching for, rather quickly, what one equals 0. That's what it does. Let's see. What is the maximum height of the ball?
6.2 meters.
So in this case here, we're trying to find the maximum height. So what do you think we're going to hit on the calculator?
Calculated maximum.
Calculate maximum. Very good. Second, calculate maximum, option 4. And again, I want to be to the left of where the maximum occurs, to the right of where the maximum occurs. So there's my left. There's my right. It's giving me a maximum. It took 0.77 seconds to reach the maximum, and the maximum occurred at 6.74 meters. So man, that goes up real fast and down. Think about it. It starts about 3 feet up, goes up to about 20 feet, and back down to the ground, and all under 2 seconds. It's impressive. That's what those values mean. Now the other ones, it's having you adjust then to what happens if this is the ball's thrown on the moon. What would you change?
T squared.
Yeah, the t-squared part. I wouldn't worry so much about that. That's more of a physics stuff that we're going to get. I mean, honestly, this came from a physics textbook. Initial velocity problems are physics problems, guys. That's all they are.
And I'm not saying.
You know what, Julie? I'm not lying. Physics is was a really cool class because you actually get tangible evidence of why math works. You can build stuff, you get to design things, you get to blow stuff up. I mean, it's really kind of cool. Well, I don't know if you blow stuff up, but you could. We built catapults.
Yeah, they built kind of.
No, but you guys built small catapults. We built one that fit in the back of a pickup truck because we could. We had no restrictions. We just built a giant thing that shot 50 feet out in the air. It was awesome. It was great. Balsa. You guys have to use not balsa wood, but like spaghetti to build bridges. We had balsa wood. Our bridge was holding like 30, 40 pounds. It was awesome. I love that class. All right, last one. Oh no, I'm out of whack here. I apologize for the writing on this one. It did not show up very well, but if you squint, you might be able to figure it out. You guys got young eyes. Your eyes are all young. You're fine. The matter of the pictures is X inches across. The length of the pictures with the mat is 40 inches. The width of the picture with its mat is 24 inches. Now this is your image of uniform width. It's telling you had the uniform width of X going around. It tells you that the interior area of just the image itself is 192, but it told you that the length, the overall length, including the mat, was 40. The overall width, including the mat, was 24. So we need to find the dimensions of the picture. Right. So am I subtracting or adding in the x's to get the dimensions of the picture? Subtracting. So my dimensions of the picture then would be 40 minus the 2x by 24 minus the 2x. And what do you have to set that equal to?
0. No. 192.
192. And then you would work it back to 0.
Why do you set it to 192? It's like,
They gave you the interior dimensions of the interior area of the pictures at 192. So when you FOIL all that out, it's going to equal 192, which means then you set it equal to 0 by subtracting it back. And then you just look for the, you just use the calculator or quadratic formula or whatever. Be careful with these. Remember how we did the border uniform width before, where you had two positive values of x, but one of them was wider than the actual dimensions of the wall. So it looks like it could be a feasible one, but you got to double check, make sure you're not being crazy, more sort of than normal. Yeah, after you FOIL it out, all out, what do we got here? 40?
So you subtract 192 from those.
Yeah, so when you FOIL this out, 24 times 4 would be what? 96, so 960 minus 40, or minus 80, x minus 48x plus 4x squared is 182. So moving things around, then I'm going to get 4x squared minus 128x plus 2, 768 equals 0. Divide everything by 4. We get x squared minus 32x plus 192 is 0. Only reason why I FOILed that out is just to make my numbers smaller. That way I have to try to factor it. I probably don't want to figure out factors of 192 to 32, but it looks like it'd be clean. I might just throw that in my calculator real quick to see if the table gives me a 0 real fast, because I know that's going to be an x plus and then x minus. Remember how to check that? If I throw this, oops, wrong button.
That last equation is your answer?
That's just that last equation was, I simplified the 4x squared, 182, whatever it was. All I did is, because I just took out a 4, just to make it easier on my brain. If I go to here, I forgot what it was. If I put in x squared, I just throw that in here and just check my table. Oh, I have a 0 at 8, and then I probably have another 0 at, well, what's 192 divided by 8? 24. So my two terms would be x minus 8 and x minus 24. The reason that I know that it has to be minus is because look at what we add. It's two numbers that add together, two numbers that multiply together to get positive, you add together to get negative. They both have to be negative. Okay. Plus, the calculator, when it gives you the 0, if 8 is the 0, that means the term would be x minus 8. So what are your dimensions? 8 by 24. Oh, I'm sorry, that's values of x's. So we have to look to check to see which one is going to work. Will 24 work? 24 is not going to work because if I take 24 minus 2 times 24, it's going to be negative. So if I use the value of 8, what's 24 minus 16? 8. Hey, what do you think the other side's going to be then? 24. There's your dimensions of the interior of it. You could have factored that. You could have used quadratic formula for that. I used the table function because I knew my leading term coefficient was 1, which meant that hopefully it was a factorable, it's a factorable offense to make it work through on that, okay? Like I said, I think I kind of ran through these real fast. There's one more, but that one's really, it's pretty easy. It's just, it's right on the table function really, or zeros. Look at, and I'm not lying, make sure you double check, go through your chapter review, test stuff on chapter 5, that's where all this stuff was in the old book. Look at solve for x still. Make sure you remember how to simplify with an imaginary. You got the word problems we've kind of gone over again, you got a ton of those to relook at. We also have, I will probably put on one of the modeling styles. I'm just going to retally which one was the one that most people got wrong. Okay. Excellent. Hey guys, you guys didn't say goodbye to Haley. She was visiting us today. They don't really like you. Hey, good luck on your test today.
Thank you.
Anybody else taking the SAT? Is it SAT or ACT? ACT, don't forget your calculator. Don't forget that calculator, because you can use that one on there. If you have that multi-view calculator, bring it with you also in case you have to simplify radically. You don't want to do it by that way.
The whole set.